Okay. So steamed fractional distillation versus simple distillation. As you said, the simple distillation is used for purification of liquids that the boiling point is significantly different and the magic number is the 80 degree. For fractional, if the difference in boiling point, it's not that significant, but it should be different, still should be different. So maybe like 10, 20 or 30 degree difference, and you have to have that difference in the boiling point. A steam distillation, however, and I want everyone try to answer this question. What would be the boiling point for in steam distillation, boiling point of a mixture? At what temperature the mixture would start boiling? Around 100 or below 100, okay? Below 100 degree Celsius. It would be less than 100 degree Celsius. So the way a steam distillation works, you have steam, which is coming from water, and another compound that is immiscible. When the compounds are immiscible, they are going to act separately or individually generate vapor pressure. Okay? If it's pure water, at what temperature starts boiling? Would the water start boiling at, if it's pure water? At 100 degrees Celsius, yes, if it's pure water. If that, what does it mean? It means that at 1 atm or 760 millimeter mercury pressure, external pressure or environmental pressure, the vapor pressure of water equals 760. The key is the total vapor pressure concept that is used in the steam distillation. So when you have mixture of two, you get the total of the vapor pressure from water plus vapor pressure from the other compound. So let's say at 90 degrees Celsius, if the vapor pressure from water is 700 millimeter mercury, because you increase the temperature, vapor pressure is going to increase. At the point that vapor pressure equals atmospheric pressure, liquid starts boiling. When you have two immiscible compounds, if the water provides 700 millimeter mercury, it's just enough for the other one to provide 60 millimeter mercury, which is very low pressure. And any compound could have, even though it has high boiling point, but at 90 degree, that's just a example, it could have 60 degree contribution, 60 millimeter mercury contribution toward the pressure. So the pressure, the total pressure when it equals to atmospheric pressure is going to start boiling. If it's open to environment and the pressure is about 1 atm, it's going to boil less than 100 degree. And this is a question for you. What is the benefit for steam distillation? Under what condition we are using a steam distillation? One more time, you could say, what's the benefit for steam distillation and why should we use steam distillation rather than simple? Very good. So for the compounds that they have very high boiling point, if you provide enough heat to boil that that compound, it will decompose. It will cause decomposition. So to avoid decomposition and do the distillation at a lower temperature to avoid decomposition, we can do steam distillation. The condition is that that compound cannot be miscible in water. So that is the condition. And the benefit would be to avoid decomposition, and also you would use less energy. Like you are going to provide enough heat to to increase the temperature to 100 degree rather than 250 degree Celsius. So, but major concern is decomposition, and we're trying to avoid decomposition. The setup for the for steam distillation is very similar to distillation of the simple distillation, with a minor difference. And the minor difference is, you see that you have here, you are using a 3-neck boiling flask. In a simple distillation, you just use a simple boiling flask. The reason we are using the 3-neck one is because we want to make sure that we have enough water in reservoir and without filling the flask all the way to the top. So we can start in like halfway full of the flask, do the distillation, and when the volume reaches to the bottom or almost, you know, gone, or you want to make sure that you should never distill to dryness. Then you start, you open the stopcock and add more of the water in order to provide more steam for the steam distillation. You cannot put too much water here, because if you fill up the flask more than 2/3, it's going to bump into the condenser. So you have to keep the level low, but have a reservoir to add more later. And if it starts drying up, you cannot open. If you use the simple one, you cannot open and get the add more water, because you can't. It's a hot setup, and you cannot open it. You're going to lose a lot of compound vapor to the environment. There is a danger of burning yourself. The steam has very high energy, kinetic energy, so when it does condense, it's going to burn your skin severely. It's worse than boiling water. So you don't want to get the, you know, for the safety, and also the techniques that we are using, we cannot open the distillation, and avoiding lose of the product or the compound, we cannot open the distillation. We have to cool it down, then open it, and that's like waste of time. So when we have this setup, it's going to provide the additional water. For collecting, we are using flask rather than open container like a graduate cylinder, because we want to make sure that this, you know, that it condenses. And if you see like lots of vapor here, you can add a ice bath here to cool down the vapor. So we're just trying to avoid the losing of the vapor, and we're trying to get complete condensation. That's why we are using closed container. And then periodically you transfer to graduate cylinder to see how much you have collected. What you are collecting today, it's the mixture of water and eugenol from the cloves. Eugenol is the oil or essential oil from the cloves. The percent recovery is around 14%. So what you recover today, let's say if you get like 1 gram and you divide that by, or if you get 0.5 grams, you divide that by the original sample, which is 5 grams times 100, that is your percent recovery, actual. The theoretical, you can take the 14, is anywhere between 14 to 20, but you could take 14 as the theoretical amount if you were going to calculate like percent. But this is a percent recovery, it's not percent yield, because there's no chemical reaction. The product is eugenol. The functional group for the product, you have phenol and you have alkene. So you do 2 chemical tests to confirm that you have the product. One of the chemical tests is to test for the phenol functional group, and the other one is for alkene. For phenol, you are using ferric chloride, and for alkene, you are using Bayer's test, which is the permanganate. It can saturate the double bond, and it changes to manganese dioxide. So you would see like a brown precipitate, or the purple color goes away. You can also use bromine carbon tetrachloride. Bromine carbon tetrachloride is the so if you take the correct, if you take the 14%, it's safe enough to say that's for the eugenol. So I just use the 14% because we don't know exactly how much of that is going to be the eugenol or the acetyl eugenol derivative of it. So you could just take the 14% for the eugenol. So we are going to do the test for unsaturation, double bond, and test for the phenol to confirm that we have the product. So it's like a quantitative analysis. That quantitative analysis, it can go to a table like a data table, just like the first experiment you did for solubility. So your data table is not just mass of the product that you have. You could have also qualitative analysis and say permanganate, the color change evidence, and then or Bayer's test and the evidence for it, and the ferric chloride test and the evidence for it. Also, it can go to the data table, and they can appear in the abstract and the abstract conclusion discussion. The experiment is simple, but the benefit of this, you're learning a new distillation class or category, which is the steam distillation. You probably would appreciate more, like essential oils being so expensive because it takes a long time, and the percent recovery is very low to extract the essential oil. And the eugenol actually has high oil content, unless it's like the oily nuts like peanuts or walnuts. Other spices, they don't have that much oil. It's very, very low. So you are starting with the 5 gram. You're adding the 50 milliliter of water. You are going to do steam distillation. Then you add more water. Continue. You're getting the cloudy mixture, and that cloudy. I said data, and your data is going to include the percent recovery, and it would include the qualitative test, which is the Bayer's test and the ferric chloride test. So going back to the procedure, when you get that cloudy solution, because is you get in the receiving flask is a mixture of oil and water. Then you're going to use methylene chloride. What's the purpose of using methylene chloride? If you have not answered any question, please answer that. What's the purpose of using methylene chloride or dichloromethane? Two names for the same compound. What's the purpose of using methylene chloride? Methylene chloride or dichloromethane? What's the purpose of using it? What, in which step you are using it? Methylene chloride, you are using it with the separator funnel. So the separator funnel is going to be the hint that this is used for extraction, right? It's extracting solvent. So you are doing the extraction. So you are going to extract the eugenol into the methylene chloride layer. Then would it be the top layer or the bottom layer? Which layer would be methylene chloride in the separator funnel? In separator funnel, you get 2 layers. So we are kind of combining 2. experiment. Okay, what is going to tell you what information do you need? Okay, what information do you need to answer that question? With the methylene chloride, with the top layer or bottom layer? Okay, what is density for methylene chloride? In step 8, it tells you what's the density. 1.37, right? If it's 1.37, is that heavier than water or lighter than water? Aqueous solution is going to be heavier, and because it's heavier, so all the ones who said the top layer, just say change that the top layer is aqueous solution, bottom layer is going to be the organic layer. In this case, it's not always the top layer being organic, because it depends on the density of the extracting solvent that you are using. Very good. Then you are going to separate. You do two extraction with the methylene chloride. You're going to collect it and add calcium chloride. What's the purpose of using calcium chloride added to the methylene chloride solution? So what you have in the methylene chloride layer, you have eugenol plus methylene chloride. Then you add calcium chloride. What's the purpose of using calcium chloride? It's a drying agent, so it's going to remove any leftover of water from the methylene chloride. Very good. It's not to prevent clumping. Preventing clumping, that is a process, or that's the indication. Very good. I'm glad that you brought that up. It's like how much calcium chloride you're adding. When you add calcium chloride to water, it would clump up. So when you add calcium chloride to methylene chloride solution, if there is no water, calcium chloride would stay like moving and separate, like a powder moving around free. But if there is water, it would clump up. So if it says to add until stops clumping, that means you add enough to absorb all the water and all the moisture to a point that it doesn't clump up anymore. So calcium chloride is a drying agent, is going to remove water from the methylene chloride layer. And then you are going to decant it, because you don't want the calcium chloride to be mixed with the oil. When you decant, you are decanting the top solution. Can you tell me what is included in that top solution at this step? What do you have in there mixed in the top solution? It would be dichloromethane solution with the oil. Very good, with the eugenol. So you have the oil plus the dichloromethane, and now you have to remove the dichloromethane. How do you remove the dichloromethane? By boiling it off in the fume hood. Very good. So boiling it off, you can use either hot water bath, or you could use low heat on a hot plate. As soon as the temperature reaches like 60, because the way it works, we already know that eugenol has a 250 boiling point. Methylene chloride boils at 56 degrees Celsius. So when you, and these are miscible, right? Because they are miscible, the one with the lower boiling point is going to boil first. So when you heat it up, the methylene chloride would evaporate first, and then the temperature has to increase before eugenol starts evaporating. So methylene chloride evaporates when the temperature reaches like 60 degrees, which is 4 degrees higher than the boiling point for methylene chloride. We are sure at that point that all methylene chloride has evaporated, because until you have methylene chloride, the temperature would stay low, because energy is spent to evaporate methylene chloride. The change in temperature is not going to be very significant. So the temperature is going to stay around 56 to 60. But when you see like increasing higher than 60, that means you have to stop. You don't want to overheat your sample, because if you overheat your sample, all of the compound, all the oil is going to decompose and evaporate. So you don't want to decompose it. You didn't decompose it during distillation. That's why you did the steam distillation. You don't want to decompose it at the end when you are recovering or removing the solvent. Then you measure the mass and you calculate the percent recovery. Any questions for me? No questions? Okay, I'm gonna have to bring my notebook for the attendance because I'm using a different setting here in this room to create my papers because I have a bigger monitor, but I have my lab manuals inside in the laptop, so that's why I had to the delay also. But I have my notebook. I'm going to bring it quickly and call attendance. Okay. Attendance. I hope that people didn't think we don't have class and they left, but Tarek, this is for attendance, please. Deja, Ashana, Elizabeth, Elizabeth, I think I saw you logging in. I just want to make sure you're here. Okay, logging in doesn't count for attendance. Answering questions and answering the attendance is going to count for attendance. So please keep that in mind. Jennifer? Alexis? Kylie? Caleb? Valentina? Mariah? Mariah? Okay, Mariah is that here. Okay. Gatania? Anifal? Anifal, were you absent last class? And if you were absent, you know that you had the opportunity to attend the 3:30 class because I'm teaching one class after your class. For anyone who missed the class at 12:30, you have the option of attending, but you have to send me email by 3 p.m. so I can send you a link for the other class. Anam? Yeah. Sammy? Cassandra? Craig? Antonia? Okay. Did I call everybody's name? And did you all answer at least one question? Okay. If you don't have any questions at this point, you can start watching the video. Thank you and have a nice day. But if you have questions, please stay to ask your questions. We don't have office hours tomorrow. Tomorrow is a professional development day. So if you have any questions, you may want to just email me. Okay? No office hours tomorrow. I tried, you know. Thank you. You too. Have a nice weekend. start watching the video, not for your class, but for the other class. I'm discovering like all this data that it comes from last semesters. It doesn't come from the recorded video. Make sure you watch the video, collect your data from the video.